Let's look at question 3 of this year 2026 NECO pass question, as we have it here that the elevation and plan of a cone are shown in figure 4.3. Draw question Roman figure 1, the given elevation, Roman figure 2, the plan, and Roman figure 3, the first auxiliary elevation on plane x prime y prime. Okay, so here we have the elevation. So this is the front elevation and this is the plan. So for the front elevation, we have the height of the cone to be 50 millimeters. Okay, and then we have the diameter of the circular base is 50 millimeters. Okay, so this is line XY and line X1, Y1 on which we are going to project the first auxiliary elevation is given here. Okay, so we have it here. So looking at this arrow here, which is inclined at an angle 45 degrees, so it means the plane x1 y1 is also at 45 degrees to the horizontal, because the angle between this arrow and this plane x prime y prime is 90 degree. Okay, so let's proceed and see how this construction can be done. So what we have to do first is to draw a horizontal center line. So I'm going to have a horizontal center line like this. So I have this. Okay, so then I'm going to draw a vertical center line, Okay, so I'm going to put it somewhere here. I will draw a vertical center line like this. Okay, so I'm having this vertical center line. So let me just take it up a little bit. Okay, so I have it like this. Okay, so then the next thing that I'm going to do is to take my compass and draw the circular base of the cone, so whose diameter is 50, the radius is 25. I will take 25 millimeters on the ruler, so this is 25 millimeters with the compass. So putting the pin of the compass here, I will turn it round and draw a circle. So here we have a circle. Okay, so this is a circle. So this circle, we are going to divide it into let me divide it into I'm looking at, because we are going to produce a curve. Okay, so I'm looking at 12. Let's divide it to 8 equal parts, because that 12 is going to take time. Okay, so I just divide to 8 equal parts, so using my 45 degrees set square. So this is this we divide into 8 equal parts. So we have this. All right, so I divided into 8 equal parts. So if this is 0, and then I have this to be 1, this is 2, this is 3, and then this is 4, this is 5. So I have this to be 6. Okay, so 6, and then we have 7. It is into 8 equal parts. So don't look at it that. So because I started from 0, so it is into 8 equal parts. The next thing that we are going to do is that we come up a bit. Okay, come up a little bit, and we draw a horizontal line for x y line. So you must draw that line. So this is my this is x and this is y, so you need to get that. Okay, so then we come up a bit and we now draw a horizontal line again, so which is going to be for the base of the cone. So from this point, from point 0, okay, so I'm going to draw a vertical line to touch this line, and then I will draw, so from point 4, I will draw a vertical line to touch this line like this. Okay, then I will also draw from 5. Okay, so from 5, just draw from here, and then from 7, so which is for both 1 and 7, the one I drew here is for both 3 and 5. Okay, we have this. Then I will now take the height from this point here. I will take the measurement of 50 millimeters, which is the height of the cone. Okay, so then we are going to connect each of these points with the apex of the cone. So this goes like this. Then I will also take a line, so from here, so to join it with this, and then from this point I will also draw a line. So from this point to touch the apex of the cone, and then the last one here, okay, for 0, I will draw a line, so from this point to touch the apex of the cone. So here we have the elevation of the cone. So all we have to do now, we need to bring out the thickness of this part. So make this line a thick line from here to here, and then so this outer line or lines, so we need to make them thick lines. Okay, we leave the inner ones. Okay, so we make this line a thick line from here to here. All right, so now having done this, the next thing that we are going to do is that we are going to set the x prime y prime line. Okay, so though its distance, okay, is not given to us, it is placed on this baseline, okay, at 45 degrees. So I'll just extend it here, and then I'm going to take my 45 degrees set square. I'll take the big one, okay, so that the work can be easily done. Okay, so then I'm going to draw the x1 y1 line. Okay, so I'll just set it this way. So with 45 degrees set square, so we draw the x1 y1 line like this, or x prime y prime line. So if this is all right, so this is x prime and this is y prime. So we have this. Okay, next thing that we are going to do is that we are going to use the 45 degrees set square to project line from each point that we have here. So let's start with the center. Okay, so with 45 degrees set square, so I'm going to draw a line. So from the center here, I will draw it as a center line like this. Okay, so so here we have the center line. So we have the center line. Okay, so next, so from this point 1, so I'm going to draw a line. I will draw a line from point 1. We are going to draw a curve. Is it going to be a curve? If I'm looking at it in this direction, it's not going to give me a curve, it will give me a straight line. So that's what I'm going to obtain. So not a curve, it will be a straight line. It's not going to be a curve, it will be a straight line. So that's what it's going to be. Okay, supposing it is auxiliary plan that we want to draw, that's when we are going to have a curve. So what we are just going to see here is just like what we have here, but it is produced on an auxiliary plane. Okay, so this is an auxiliary plane. We have set auxiliary plane here. Okay, this is just normal orthographic planes, so vertical plane, horizontal plane, but in this case we have auxiliary plane. Okay, as we have set it. So when I'm looking at it in this direction, what I will see is a straight line. So it's going to be a straight line, so I don't really have to. So what I'll just do here is that I'm going to so I will see from, so I'll just transfer this just to touch this line. Okay, then I will come here. Okay, so I'll come here and draw at this point 5. Okay, so I'll just draw. So from here with 45 degrees set square, it touches this. So that's what I'm going to have. Then I will take the height. So the height of the elevation, so which is 50. I'll come here, take a measurement of 50 millimeters on this line. So this is 50 millimeters here. Okay, except if I want to draw the, okay, so let me just draw it. So the line at this point, so line at this point, look at it. So both are 2 and 0, so they're in line together. So I'll just draw like this. Okay, probably, so the one that will be there, so I will also, so 4 and 6, they are just in line. So I have this. So what I just do is to connect these points together. So for the extreme ones, so which is this one and this one, so we are going to make them thick lines. So we make them thick lines. So here we have what we join this together. Okay, so and then so we also join these points together as a thick line like this. Here we have this. Then other ones, so I'm going to just make them thin continuous line, as I usually use my red pen for that. Okay, so and then I will also draw this. like this. Okay, so here I have the first auxiliary elevation like this. So we make this line a thick line from here to here. So here is the first auxiliary elevation. Okay, so this is what we are asked to do to produce the first auxiliary elevation of these figures. As simple as I've done it here. Thank you and God bless you.